All right, so for today's deep dive, we're looking at something with a, let's just say an intimidating part number.
It sounds like a component from a spaceship, yeah.
The NTI DP8K-FO-15M-MMLC. But when you really boil it down, it's a 15-meter cable.
A $190 cable.
Exactly. And that's the part that makes you pause.
It's a price tag that, immediately makes the average person think, no way. If you're just connecting a monitor to your laptop, this is complete overkill.
But it's not for that. This is a problem solver.
It is. It solves a very specific, very real physical limitation.
And that limitation is basically copper failing. We all know standard cables just hit a wall when you try to push high-res video over long distances. But why?
It really comes down to basic physics, attenuation and resistance.
So the signal just degrades.
It does. As that electrical signal travels through copper, it loses energy as heat. The longer the wire, the more signal you lose. And when you're dealing with a ton of data like uncompressed 8K video, the frequency is so high the signal just, well, it falls apart.
It's like shouting across a football field.
That's a perfect analogy.
Yeah.
By the time your voice gets to the other end, it's just noise.
So this NTI cable uses active optical tech to get around that. But I notice it's technically a hybrid. It has fiber optic cores and copper cores. If fiber is so much better, why keep the copper at all?
That's a great question. It's because fiber is fantastic at one thing, transmitting light.
But not electricity.
Exactly. Your computer and monitor, they need to have a little conversation, the whole EDI handshake, so the PC knows what resolution the screen supports.
Right, so it knows what it's talking to.
That data and the little bit of power needed to run the cable's internal chips, that all travels over the copper strands. The fiber is purely for the heavy lifting.
For the high-speed video data itself.
The really heavy stuff.
And that explains the insane bandwidth numbers here. We're talking 32.4 gigabits per second.
Which is staggering. Yeah. It's enough for Ultra HD 8K at 60 Hz, or for gamers, 4K at 120 Hz.
And because it's traveling as light, it's pretty much lossless. This one is 15 meters, but the tech itself can go up to 100 meters.
100 meters with zero signal degradation. But there's another huge benefit to using light that goes beyond just distance.
The documentation mentions stuff like medical imaging and airplane video systems.
That's all about immunity to interference, RFI, EMI.
All that electrical noise.
Right. Copper cables can act like antennas, picking up noise from power lines or heavy machinery. Think about a hospital near an MRI machine.
Oh, the magnetic fields there must be intense.
Insane. A copper cable could get artifacts in the image or just lose the signal entirely. But glass fiber, it's immune. It's not electrically conductive.
Okay, so something that usually drives me crazy with active cables is the power. You always have that extra USB cord you have to plug in, a wall wart.
Dreaded pigtail.
Yeah, but this one doesn't have one. How's it powered?
It's pretty clever. It just sips the tiny amount of power it needs directly from the DisplayPort on your computer.
So it's powered by the source device itself.
Yep. It's just enough to run the little electro-optical chips inside the connector heads.
Which brings up a really important quirk, though. Because it's converting electricity to light on one end and back again on the other, it has to be directional.
Oh, absolutely critical. You can't just plug it in any old way. The connector heads are actually labeled source and display.
And if you get them backward,
you get a black screen. Nothing.
Yeah.
It's a very common installation mistake if you're not paying attention.
I was also just surprised by the build. You'd think something with glass and copper would be thick and heavy, but it's only 5.2 millimeters in diameter.
And it has that extreme operating temperature range, -40 up to 158 Fahrenheit.
Which tells you it's not for your desk.
No, that's for running through ceilings where it might freeze or bake, or for outdoor digital signs. It's ruggedized.
It just highlights how much invisible engineering is going on just to get an image from point A to point B.
I mean, think of it this way. A copper cable is like a two-lane road. It's fine for light traffic. But your 8K data, that's a massive convoy of trucks.
You're going to get a traffic jam.
A huge one. This fiber cable is like a dedicated express train. It doesn't matter how heavy the cargo is, it moves on its own track and bypasses all that traffic.
It's a good reminder that as our displays get sharper, the pipes connecting them have to evolve just as much.
They absolutely do.
Which kind of leaves a final thought to chew on. If we already need this kind of hybrid fiber optic tech just to handle 8K reliably, what kind of engineering are we going to need when 16K becomes the new standard?